implementing stack in linked list is done, all thankful to the function we have done before. All the rest you can use it the same. Is empty and so on, all these functions, okay? You can use them all the same. Make sense? All right? All right. Now, one of the application of stack is to check that every, okay, we check what the open parentheses, bracket, and bracers. By the way, this one we call it what? What we call this? Correct terminology. What is it?
Parentheses.
Parentheses. This one.
Braces.
No.
Square brackets.
Square bracket or brackets. This one is what?
Braces.
Braces. Okay? That's the correct terminologies for it, right? So every open bracer, I should have closing bracer. Every open parentheses, I should have a corresponding closing parentheses, correct? So I'm come here, right? So the example I have here, so I have brace, bracket, and parentheses must correspond to its left counterparts. So the example here on the left, is this legal or not?
Illegal.
Yes, this is legal. How about this one?
No.
Obviously not legal. I have opening square brackets. Here I should have closing square bracket, right? Okay, or closing parentheses, then closing square brackets, right? Either one is okay. So how does stack utilize this? So here is the algorithm. Make an empty stack. So I make an empty stack. I come to here. So I make an empty stack. Okay? What I do next? Okay? Read the characters until the end of the file. Okay? So let's do the first one, which is opening brackets, parentheses, parentheses, closing bracket. I'm doing this. I'm reading one after each other. Okay? So, reading the character until I finish. If the character is an opening symbol, right, push it onto the stack. So I come to here. Is this opening symbol? Yes, I push to the stack. I push the button. Right? Is this opening symbol? Yes, I push the stack. Is this an opening symbol? Opening or closing? Closing symbol, right? Okay. If this closing symbol, then what we do, then if the stack is empty, report error. Is my stack empty? No, so it's not error yet. Okay? Next. Okay? Otherwise, pop the stack. And if the symbol popped is not the corresponding symbol, we report error. Meaning that I come here as a closing symbol. I need to pop the symbol on the top. Which one the symbol on the top? Opening parentheses, correct? Do they correspond to each other? Yes, means okay. If I find here on the top something like this, then I have closing symbol. What does this mean? Okay. Sorry. Yeah. For example, here closing, here what? I have square bracket. Then this is right away I report error. Okay. So this is actually how the compiler works. At the end of the file, if the stack is not empty, report error. So I come to here. Is this okay? Correspond to the opening symbol? Yes. What I do? Pop. I come to here. Is this correspond to this one? Yes. Pop. Is my stack empty? Did I finish reading everything? Yes. Is my stack empty? Yes. Then everything is okay. Okay. My symbol all okay are okay. Mean everything is correct. Now let's do the other one. We do the other one. Okay. So what we have bracket. Yeah. Okay. So is this an opening symbol?
Yes.
Push to the stack. Opening symbol?
Yes.
Push to the stack. Opening symbol?
No.
No, I pop. Which on the top of stack? Opening parentheses. What is this? Closing brackets. Do they correspond to each other? No? Right away, error. Okay? Right away. They don't correspond to each other. Right away, I report it is error. Okay? So, very simple, right? This one application of stack. So any questions so far on the stack? Very simple. Right, very simple to do. Okay, next we have Q. Q, I always say that is actually a little bit more complex than stack. A little tiny bit more complex. Right? So Q is, you know what's Q, right? You go to the cinema, you go to a train station, you stand in a queue. You are the first in the queue, you'll be the first one to get the ticket. You are the last in the queue, you'll be the last one to get the ticket, right? And if you go and you see the queue, do you queue at the front or queue at the end? And otherwise, everyone will fight with you, correct? You skip the queue. Okay? So you queue at the end, right? Not the front. So we need to think about the basic operation of the queue. We have, in the stack, we have push and pop, correct? In the queue, we have what? In-queuing and de-queuing. In-queuing means we go to the queue, okay? We stand at the end of the queue. De-queuing is when the person gets the ticket, and de-queue means be removed from the queue. All right? Implementation is the same. We have array and linked list. So like stack, a queue is also a list. However, with a queue, insertion is done at one end, while deletion is performed at the other end. Obviously. So insertion one end, deletion another end. Accessing the element of the queue follows a first in, first out. First one stand in the queue will be the first one to get the ticket, correct? And this one, in short, we call it FIFO. Not FIFA, FIFO. The one like in football laughing. Here and there. Okay. Okay? So, FIFO means first in, first out order. Like customer standing in the checkout line in the store, first customer, okay, will be the first one to be served. Okay? So the idea here is a queue is another form of restriction. It's just like we're dealing with array, right? Stack have restriction, a queue have a little bit more different restrictions. And we said that insertion is done at one end and where deletion performed at the other end. That is the difference between stack and a queue. Stack all the time. Deletion, insertion, one end, correct? The queue, insertion, deletion, each one, either the beginning or the end. Okay? So the basic operation, we have in queue, insert an element at the rear of the list. So we call it rear, okay? The end or rear of the list, okay? Then dequeue, delete the element at the front of the list. So we have rear and front, okay? So this is the queue. I all the time add to the queue. I mention it again here because some students confuse between in queue, dequeue. In queue, you stand in the queue at the end. Dequeue, you are removed from the queue after you get the ticket, let's say. Okay? So it's a first in, first out. All right. So, in queue and dequeue. Primary queue operations in queue and dequeue, like check out and install. Okay, in queue, insert the element at the rear. Dequeue, remove the element from the rear. Let's implement it on the array. Correct? Okay. So now, here, what is suggesting for us? Okay, the array will look like this. If it's full of elements, right? Which one is the front? Array of what?
0.
0. Which one is the rear? The end. Correct? Okay, but I will not get an array or queue already full. I will need to fill it all by myself, correct? So, okay. Before we go there, this is what I like to do all the time. I try to test you out. Why I try to test you out before we look at the best way to do it, okay? I want your input. I want you to think critically. Give me the solution. Then we find what are the issues with your solution, right? In this case, you will not make mistakes in the future. All right? So I have an array like this. Okay? 1, 2, 3, 4, 6. That's good enough. So this is my queue. In this is 0, 1, 2, 3, 4, and 5. Okay? Now, I have front and rear, right? Okay. So at the beginning, I want to insert the first element in the queue. Let's say 5, the first element. Let's do 10, 20, 30. Okay. The first element, 10. So why we do 10, 20, 30? So we know first element, second element, which one we insert. Okay. So insert 10. How to insert 10? Help me out. How to insert 10? I need to define rear and front, correct? At the beginning, what they are equal to? Which one 0? Wow, okay. First time get the correct answer. So F is a front, okay, and R is rear. And actually what your friend said, I make it 0 and minus 1. Actually, perfect. It's a perfect answer. I can make them both 0, no problem. What's the difference if I make it minus 1 or 0? I insert, then do plus plus, or I do plus plus, then insert. We have seen this in a stack, correct? Exactly same like stack. But the only difference between stack and queue, I need to have front and rear, correct? Now, look here. What do we do next? I want to insert 10. What should I do? Yeah. Rear plus plus. Rear now is what? 0. And I insert 10 here. Correct? Next, I want to insert 20. Same thing. Rear plus plus. Okay. Then insert 20. Then I insert 30. Then insert 25. So you don't only sorted. Okay. So the last value of rear like this. Correct? So far, okay? Okay. Which one front? 10. Which one rear? 25. Right? Okay or not? This is what in Q or DQ I'm doing? In Q. How do you do DQ? DQ I remove from where? I remove 10. What should I do? How to remove 10? Front plus, fantastic. Okay? Front plus plus, good solution. But, look like this. Happy? This is the front of the queue, end of the queue. Correct? Now let's say I insert another 2 elements. I insert 30 and 11. My rear now is here, correct? Okay or not? Let's say I DQ again. What you did? Front plus plus, correct? Why he told me front plus plus? Because if I move front, my queue begins from here and up to where? To here. It's from here. But notice what happened to my array size. My array size used to be what? The entire array. Now how many positions I lost? 2. What happened to my queue? It's getting smaller and smaller and smaller. Right? So this is actually, so far this one, if I now want to enqueue, I will have issues later on. Okay? But if I remove, that's okay. So I'll keep it like this. Later we'll find what is the solution for this one. So here, okay, the size stack can be implemented as array and linked list. So dynamic queue have the advantage over static queue as dynamic stack over advantage over static stack, right? Static mean what? Implementation using array. So the size of the array fixed at the compilation time. The stack cannot shrink and cannot extend the size, right? Similar thing, same thing with queue. So there are different algorithms to implement enqueue and DQ. A naive way, okay, a naive way is what to do. What's mean naive?
Simple.
Huh?
Simple.
No. Naive is not simple. Naive is not so smart, I would say. Okay? Naive way means not a good way to do it. Okay? Not the best way to do it. When enqueuing, the front index always fixed. So here they are suggesting to fix the issue of the size all the time, shrink, 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 right? Because my array shrink. What we do, we keep the front at the beginning. So now when I DQ, what I do, shift all the elements one position to the left. Right? Okay? I shift 11 here, 30 here, 25 here, 30 here, 20, I shift it to here. Okay? Then what I do to rear? Rear also minus minus. You understand? Everything will be shifted one position to the left. Okay? Why this is a naive way? Okay? So when enqueuing, the front index always fixed and the rear index moves forward in the array. This is enqueue, sorry. Okay, let's see the NQ. So the front index fixed, I insert 3, real plus plus, insert 6, real plus plus, insert 9. Okay? So when NQing the front index all fixed, then what about when DQing? The elements at the front of the queue is removed, moving all the elements one position to the left. Meaning that this one fixed, right? I used to be 3, 6, 9, right? Yes. I used to have 3, 6, and 9. What we do? Shift 6 here, shift 9 here, and the rear reduced by 1. So I shift 6 here, shift 9 here, and rear used to be here, rear comes to here. I DQ again, shift 9 here, and the rear minus minus. Why this is naive way? You tell me inefficient.
Because it moves every time, losing time.
What's the complexity now?
And 2, and to the power of 2.
To know the complexity is, in the worst case scenario, how many elements I'm shifting?
N minus 1.
N minus 1 or n elements, right? So I'm shifting n elements. What's the complexity going to be? Big O of n. Why squaring?
It moves.
More complex. All right. So it is more expensive, correct? Okay, to shifting all the elements. The better way is, let's go back to the previous one here. Okay, what was first? Was here, front here. Okay. So this is a naive way to do it. Why? Because not really efficient. A better way to do it, okay, with Q here implementation of the array, better way, when an item is enqueued, make the rear index move forward. Okay? So with the item enqueued, the rear index, okay? Let's go back to the beginning here. Let's assume the queue look like this. This is the front, this is the rear. So when I enqueue, what happened? Add to the queue, rear index moving forward in the array. So I do rear index plus plus, and I insert there. Okay? Nothing changed, the same. All right? So when an item is DQ'd, the front index moved by one element forward. What? Now if I want to DQ, what happened to front? Move one element forward. Okay? Meaning that I DQ now, front becomes what? Pointing at value 20. Correct? Beginning of my queue is what? From 20. End of the queue is what? 25. Okay? So now here, moving one element toward the back of the queue. Thus, removing the front item, so no copying to neighbor element is needed. If I move the front, I don't need to shift all the element one position to the left. Right? So now my DQ and Q, what are the complexities for both? 1. Big O of 1, constant. It doesn't rely on the size of them. But the issue here is, you notice that my Q size is getting smaller, correct? My Q size is getting smaller. So looking here at this example, I have here is front, here is rear. So I insert 4 elements, right? So after I insert one more element, I insert at the rear. DQ one element, DQ from front. NQ 2 elements, in DQ to the rear. NQ to the rear. DQ 2 elements, DQ from front. And NQ 2 elements, NQ to the end. What happened now? My Q begins from here and up to here, correct? Similarly here, my Q begins from here and up to here. And after a few operations, if I add 2 more elements, I add 40, my rear will be here, and I add 50, my rear will be there. Correct? Now if I DQ again, front will move forward. Front will move forward. It's like 20 and 10, they are gone from the array, right? They've been gone. Right or not? My front from here, rear to here. So now, I want to NQ one more element. I want to add to the queue one more element. What should I do?
Move F backwards.
Move F
Backwards. Yes. Add
What?
and move.
Mean shift all the elements one position like this?
No, add one element and F minus minus.
Add one more element, then?
F minus minus.
Okay. So, no. Another suggestion, what we should do? Make r equal 0. What do you mean by make r equal to 0? So if I reach the end, say to me that since I don't have more elements, and my Q is supposed to be 6, so I should have able to hold 6 elements, right? But here I have only 4. So I have 2 more spaces available. Your friend there told us that we'll move R back to the first index. Okay, can we do this or not? Can I move R to here? And I insert. I insert 60 here. Can or cannot? Which one are front? How do I know which one is front? I don't know based on the numbers here. I don't care what are these numbers. I care which one is front. F is front. Front now pointing at which index? 2,
Sure.
right? So my front array here, the Q here, begins from front and up to what? To rear. Let's print the array, right? So let's print the Q. I print front plus 1 plus 1 plus 1, correct? Now I print 50. If I do plus 1 and I see the size of the array, what should I do? Go back to the beginning. That's it. That's the whole idea. So looking here, implementation using circular array. This is what we call it, circular array. Using a circular array, when an element moves past the end, a circular array, it wraps around to the beginning. Wraps around means go back to the beginning. So the array will look like a circle. Right? Okay. So here, imagine the following. The same idea here. We are InQ, DQ, InQ, DQ. Then I have my array look like this. Here all empty. This is my front. This is my rear. Now I want to InQ4. What I do, I exceed the boundary of the array. And if I exceed the boundary of the array, what should I do? Go back to the beginning. Simple, right? So I go back to the beginning. I insert 4 over there. So after InQ4, the index move, okay? Okay, move from 3 to 4, okay? So look here at this example, which is more clear. I have the front here, the back here, correct? Now what I want to do, I want to InQ1. Now I increase the back by 1. Did I exceed the boundary of the array? What I do, I go back to index 0. So I insert 1 here. After InQ3, simply back plus plus, insert. Did I exceed the boundary of the array here? No, insert. No need to go back. Here, after InQ3, here, after DQ, now. So, imagine the following, right? All the time, front and rear will move forward into the array, correct? So, later, I DQ to 30, I DQ 25, I DQ 40, and I reach here. My front here, my rear here, correct? Is it possible? Now I want to InQ. What should I do? Rear plus plus, correct? And I InQ 70. So rear will be what? Move plus a plus, and I insert there. So my Q will look like this so far, correct? If I want to now DQ, I DQ from where? Which one I remove from front or from rear?
From front.
Front. So I want to DQ 50, correct? So I DQ 50. I remove 50 from the array. What I need to move to the front plus plus. Front becomes what? 6. Did I exceed the boundary of the array?
Yes.
What should I do?
Go back.
Go back to them. What happened? My Q begins from front and up to the Make sense? Okay, so it looks like a circle. So here, okay, front was at the end here. Now I DQ. What will happen to front? Go back to the beginning. Correct? Now after DQ one more time, notice now front and back pointing at the same index, correct? Which value 3. Then later after DQ, what happened to front? Will bypass the back, correct? Right or not? Okay. Bypass the back. Now I DQ one more time. Front will be here. Notice here. Let's do the same thing here. Look. Here I have rear, correct? Now I DQ from where? From front. What happened to front? plus plus. Correct? They are the same elements. Now, how many elements I have in the queue left? Only one, correct? This one is like is gone. Is like is gone, right? But can I actually remove element from the array? I don't remove it, right? All the elements are there. All here, 60, 20, all the elements still remaining in the array, right? Now I DQ one more time. Let's remove that one. I DQ one more time. What will happen to front? Plus plus. Front will be here. Correct? Okay. Now it's like this 70 is gone. Now I have what? Empty queue. So can you tell me, how can we tell the difference between empty queue and full queue? How do I know this is empty queue? How do I know? It could be full as well, right? It could be my front, start from here, 10, 20, 30, 40, 50, or 60. It could be actually full, or it could be what? It could be empty. Can I distinguish between them? Cannot. We cannot actually distinguish between full and empty. That's the issue with this implementation. But there's a simple solution for it. Okay? So empty or full, empty queue, all right? Front, back equal front minus 1, right? The back is one position before the front. This is what? If it's empty. What about full? Same positions exactly. It's either this is full or all are gone. Okay? All same positions. Okay? It's the same. So, okay, so reason and values represent n plus 1 states, right? So what are the solutions for this? How to solve this issue? How to tell the difference between full and empty? What we should do? Give me a solution. Huh? That's it. That's the solution. I create a variable. Every time I do enqueue, what I do to that variable? Plus plus. Every time I dequeue, what I do? Minus minus. If the value equal to the size of the array, or n minus 1, sorry, what does it mean?
Full.
Q is full. If it's equal to 0, what does it mean?
Empty.
That's it. Okay. So you use a Boolean variable to say explicitly, okay, whether the Q is empty or full. Okay. Make the array size n plus 1 and only allow n elements to be stored. Okay, this is also we can do. Use a counter of the number of the elements in the queue. So far okay or not? So now let's try to implement it. Before we look there, okay, I have my array like this, right? What I need? I need front and I need rear, correct? I need two variables, front and rear. So I come to here. All the rest, okay, this is class Q, Q size 10, same like the stack, okay? This is, okay, Q, the destructor, fine. Do I have to deal with it? So is empty is very important, is full is very important, right? Okay, both of them are very important, okay? We know now how to do empty or full. You go there and see. Now, enqueue is what? I enqueue a value, correct? DQ is what? I need to return a value, right? But in this case, we make the DQ Boolean function either will be true or false, right? Either the DQ is successful or not. And notice how I pass X. Pass by what? So I can use it in the main. Okay? Then display the queue. Later we talk about displaying the queue. Now what I have the members, I have front, F, rear, and counter, right? Front obviously for what? It's obviously for what? Rear is the same, okay, at the end of the queue. Counter is what? To count the number of elements. Now, of course, when I call the constructor, I need to initialize the counter, whether 0 or minus 1 is up to you. Start from 0. So if you have 0 elements, this is what we counted. Maximum size, and we know what is this one, right? Values, double star, is an array, correct? A pointer. That explained on Friday is exactly the same. So all of this one are the explanation. All right. Now let's look here. So first I have what? My constructor, right? Q constructor. What I do? What is this one values? Is the array, correct? is dynamically initialize array. We explained on Friday. That equal to the new double size, in this case, let's say 10. Maximum size equal to what? Equal to size. Front equal to what at the beginning? You're from there. Equal to 0. Rear equal to what? -1. What about counter? And that's it. Okay, the rest we already explained it. All right. Let's look now at Q. Okay, is empty. If that, how to know is empty or not now? What we said, if counter equal to 0, mean what?
Empty.
Empty. So if counter equals 0 is true, okay? Sorry, if counter is any value other than 0 is false, mean, okay, it's not empty. Otherwise, it is what? True. Okay, so if the counter is 0, it is true. Is full is what? The counter less than what? Size of the array. Okay, the counter is still less than, just like I less than n, right? If it's still less than n, okay, then return false. Okay, it's not yet full. Then if it is equal, return true. Okay? Where we're going to use this function is empty is full?
In the beginning.
When I want to enqueue, which one I use? Is full. When I want to dequeue, which one I use?
Is empty.
Is empty. Okay, and that's it. All right? So, the first function is enqueue. What I need? Double X, right? I need to know the value I want to enqueue. So what I need to check first, whether the queue is full or not. Okay? Then, if it is full, I print out a message. Sorry, it's full, we cannot add anything to the queue. Else what I do, I increase the read by 1 and I insert, right? I increase the read by 1 and I insert. Some of you now completely shocked. So I have front and rear, right? Increase the rear by 1 and I insert. So I increase the rear by 1 and I insert 10 over 10. Okay or not? Okay, now rear is here. Insert again. And rear moving through the array. Okay, then here 20, 30, 40, 50, and let's say the rear is here. Okay or not? Okay. What we set down, let's say I dequeue from the array. What I do to front, let's say front begins from here and rear reaches to the end. Here I have 60. Okay? So now, help me out with this. Here when I want to insert, obviously I want to increase the rear by 1 and I insert in that position, correct? So what is here? I increase the rear by 1, but what is mode size? What is this one? Why I'm doing mode size here? How can I go back to the beginning with mode size? So that, remember that when we said when I reach the end, what should I do? Go back to the beginning. I can write if simple if condition. If rear equal to n, the rear should equal to what? 0. I reset it to 0. That's it. This is the solution. A better solution than that, what I do, mod the size. Correct? Now, if I want to insert now rear plus plus, correct? Rear equal rear plus 1. What's the value of the rear now? 6, correct? 6 mod 6 equal to what? 0. Equal to 0. Then what will happen to rear? We go back to the beginning of the array. Make sense? Okay. Better than write if condition and so on, I can just write mod the size. If rear plus 1 equal to 1, 1 mod 6 equal to what? 1. 2 mod 6 equal to what? 2, and so on. Until it reaches to 6, meaning that the mod will limit my rear from 0 to the size minus 1. Correct? That's it. That's the idea. So what I do here, values of rear equal to x. If I insert one element, what I do to counter? What I do to counter? Plus plus. So I increase the counter by 1. Okay? I return true, meaning what? My enqueue is successful. So my queue is not full, and I was able to enqueue. Now dequeue going to be simple, right? I pass reference x. Tell me why. Okay? tell me why I pass reference X and Boolean. Why I need both? So first I check is empty, right? Okay. So I have the function is empty. If it's empty, then I cannot DQ, right? And nothing to DQ, nothing to remove from the queue. Else, I'm doing here. Now tell me, why I have Boolean and I have X? Remember last week what I said about stack? I told you we can make the function Boolean, and I can use this one because how to know it is successful or not? Because if I return 0, who said 0 is not successful? Maybe I had 0 in the queue. Maybe I have -1 in the queue. So no matter which value I return, it could be element of the queue. Correct? To avoid this issue, what I do, false and true. If it's false, that means there is nothing to return. And if it's true, there is something to return. But the idea here, every function I can return only one value, right? I cannot return 2 values unless it is an array. But here, I want to return one value, which is Boolean type, and one value is what? Double type. So what should I do? I pass by reference. What? I pass by reference, right? This X, I pass it from where? From the main, correct? I receive it here. So whatever I change on X in this function, the X in the main will be the same, correct? And that's why I don't have to return 2 values. Okay? Now, what I do, retrieve the value at the front of the item. X equal value of front, correct? Why? Okay? Just so the value here will be updated later on. Before I increase the front, I need to write X equal to the value of front. Mean X equal to what? To 30, correct? X equal to 30. Now what I do to front, front equal front plus 1. Why I'm doing more the size?
To go back when it's needed.
Yes, just in case if more exceed the boundary of the array. What I do to front, go back to the beginning. Alright? That's it. Every time I DQ, what I do? Counter minus minus, and I return true. Okay? So this is the main, this display, display function. Hey, don't look. 7. I want to display the queue. How to display the queue? Help me out. For loop. Loop begins from where?
From the front.
Huh? Front. Ends up to where?
Rear.
Help me out. Okay. For, do it up. Let's do it up there. For int, I don't need int. I equal front. Then? Sure. I less than?
Front.
Counter or rear?
Front.
Okay. Because some of you will think, oh, I should print because the queue could look like this, right? So I print from front to queue, front to rear, right? I start from front, I less than what? I less than rear, then what? I plus plus. Right or not? Because I should have not give you the example, the rear here. I should give you the example here. Then you will tell me, I print from front to rear. Print array of 2, 3, 4, and 5. Right? But actually, I should print from where? From front and to where? Okay? He said, I less than counter, right? Let's look at this as well. I less than counter. Then I plus plus. Is this correct? Let's see here. Let's say the R is here. Is this correct or wrong?
Yeah, this is correct.
Correct? Okay, let's do it. I begins from where? From 2, right? What is counter? How many elements I have?
5.
So how many elements I'm going to print?
4.
Look here. I plus a plus, right? I'm going to print how many elements? 4, right? Imagine the following. Imagine the front is here. What's the value of front? 4. What's the value of counter?
3.
Is 4 less than 3? No. Will I print anything? Condition, right or wrong? Wrong. What should I do? Give me solution. It's one all the time. That's why I said don't look at the solution there. Can anyone solve it for me? Give you a hint? Or do you want to try? Why you start from front to counter? Right? Counter is counting how many elements you have in the queue, correct? Why start from front to counter? Why not from 0 to counter?
Yes.
Correct? Because I'm printing how many elements? 3 elements. So my counter now 3. So from 0 to 3, I have how many elements? 3. So I equal to what at the beginning?
3.
I equals 0.
0, yeah.
I less than? Counter. And I plus plus. Correct? Now I'm printing how many elements? 3 elements, right? But the issue is my array, my front doesn't start from 0, correct? So how should I print the C out? What the C out should look like? I see out array of what?
Array of front. Array of front plus plus.
No space. And this board is so small. Okay. C out array of
Front.
array of front. Of course, I have to start from front. Plus I. F plus I is correct so far, right? Let's trace it. I print, what is the value of front? 4. 4 plus 0, which one? 50, correct? Which is 4. Then what I do, plus a plus. 4 plus 1 equal to what?
6.
5. I print 60, correct? So I printed 50. I printed 60, right? Now my front is here. Front plus what? Plus 2 equal to what? 6. Do I have array of 6?
No.
So just in case, if this element exceed, if this one here exceed the boundary of the array, what should I do?
Mode max size.
Go back to the beginning, right? How to go back to the beginning? Mode what?
Max size.
Okay, max size or n?
N.
Easier
Yes.
for me, n. Okay. Make sense?
Yes.
What the size of the array? This is how I print. Thank you. Okay? Yes?
And it is the same as counter in this case.
No, not same as counter. No, I'm going back to the beginning. It's not related to the counter.
The counter
The
is
counter now is 3. If I do mod 3, what will happen? 6 mod 3 is what? Okay? So that's why it could be not go back to 0. All the time we do what? Mod the size of the array, not the counter. Here, I want to print 3 elements, right? This is what I want to print. Here is different thing. Here I want to go back to the beginning. All right? So this is the display function. I begin from 0 until where? Counter, right? If I equal to 0, C out, L, C out, okay, for example here, I'll do what? C out, array of what? Front plus I, mod the maximum size. Correct? And that's it. I'll do this one. This for look at all the rest are not necessary. Here, all what to do here, I want to do tab, tab, tab. I want to print front. Okay, if I equal 0, I want to write front. Then tab, this is the front of the queue, second, third, fourth element. Then I want to print 3. Not necessarily print this, and put the tabs. All what you need, this for loop, and this C out. That's all what you need. Okay or not? That's it. Stack and queue finish. This is the function, main function of the queue. Later, when you want to go back home, you can try it. We have Q5, right? And this one from x equals 0 and this 5, in Q5 element, and so on. Okay, in Q5, display the Q, double value, all right? Then I pass the value to the DQ. Now, whatever I change in this value in that DQ function, it will return it here, and that's it. Okay? So far, okay? All right. Then, implementation based on linked list. So can I erase this? fine. I erased already. We can solve with this one very fast. Implementation based on linked list, right? Okay. Okay, let's finish it and give you back. So this is my linked list, correct? Before looking at anything there, right? This is my linked list. My linked list begins from where? From head. And up to where? The last node pointing to what? Pointing to down. Now, I need to define which one front, which one rear. Can I make head front and rear at the same time? Cannot, right? Now, which one is the front, which one is the rear? Which one you want to make it? Logically, front should be the head, correct? Front should be head, and rear should be what? The last node in the list, correct? So, this will be front. This one will be rear. But how to do this one rear? How to make it the last node equal to rear, right? This is one thing we should keep on mind. So I have here, I declared front and rear, correct? And I have what? Counter, just to count how many, okay, nodes I have in my linked list. Okay, on my queue. Actually, the whole implementation is the same as the list, very similar to the stack, right? Now, front, if I want to dequeue, so this is the front, this one the rear. I want to dequeue, what should I do? What dequeue mean? Remove the element. I remove which element from where? Front or rear? Right? From front. So the front of the queue should be removed from the queue first, correct? Right or not? Okay, now. I remove from front. How to remove front? Have we done code before to delete the front, delete the head? Yes, we have done. How to delete head? Just head equal head next. That's it. Done. One line of code is enough. And I need to clear the memory, of course, right? Have we done this before? Yes. Which one? Which one? Delete front. Now, this is equivalent to what? DQ. In queue is where I add to the queue from where? To the end, right? Have we done a code to insert at the end? Simple, right? Just keep going until next equal to null, then I insert there, right? And that's it. We have done both actually. You don't need to study all of this. All of this one is like a luxury. Want to make it the function more beautiful, make it looks more complex, but all of this are not unnecessary. You can go back to insert a node function. What you do? Insert front, delete front, or insert at the end. I can use delete front. We know how to delete front. We have done it in the stack as well, with similar to pop. Actually, DQ and pop, they are exactly the same. Pop is what? Remove the top. Which one the top? The head. DQ is what? Remove the front. Which one the front? The head. So both DQ and pop, they are the same. Only difference is what? I cannot insert here at the beginning. Insert all the time from the end of the queue. Okay. Now look here. I have queue. This is a constructor. Okay. Notice what I have here. Front equal rear equal null. Who can tell me why at the beginning both of them we did equal to null? And what's the point of rear? What's the point of having rear here? Look down here. I have 2 pointers. Node star front, node star rear. Why I have 2 pointers here? Front, obviously, why? Front of the queue. What about rear? Notice now, if without this R, rear here, I want to insert to the queue, I need to start from where? From the head, correct? I write current equal to head. Is current next equal to null? No, current equal current next. Is current next equal to null? Current equal current next. Current next equal to null? Yes, I insert there, correct? What is the complexity now of insertion? Big O of n. But if I have a pointer all the time pointing at the end of the linked list, what I can do? Rear next equal to what? New node, and I move the rear one position to the end. Make sense? I repeat, if I want to insert now I declare a new node, right? What I do, this is the new node. Real next equal to new node. Now this one not equal to nil anymore. Now it's not equal to nil anymore. I connect it. Now, right? I connect them, right? Now which one should be the real? Node 30 or node 40? So what I write? Real equal to what? Equal to the new node. The real will be. And done. Okay or not? So far okay? But why at the beginning? Do here. Why at the beginning both of them equal to nil? So I come here, both of them, front and rear, both of them equals to nil, right? Now I insert the first node, correct? I insert node 10. I'm just redo this from the beginning. I insert node 10, right? This one will be the head, right or not? Okay. Now what do I need to do with the front of rear? Front should equal to what? And rear should equal to what? Okay. That's the first time I insert a node. Now every time I insert a node, what should I do? Now I want to insert a new node, right? I insert at the end, right? Do I have the end? Which one the end? The rear, correct? Okay. So how to insert? I declare a new node, right? I write end, new node. What I do? Rear next equal to what? New node. And rear now equal to what? To the new node. Now I want to insert this in node 20. Now I want to insert another node, right? Okay, node with that value 30. And this is what? Okay, let's say also now is the new node. What I do? Rear next equal to the new node. And rear equal to that new node. Two lines of code. That's it. And this is all the time in queue to the linked list. Make sense? Where did I go? Keep pressing. All right. So here I have, that's why both of them equal to nil at the beginning. Okay? Now Q I have a double value, while is empty, DQ the values, this is the destructor. I'm just destroying the entire queue. Okay, delete one by one. Okay? Then is empty. I have a function to know is empty, right? How to know the queue is empty? Either I use counter, or both rear and front should equal to nil. Correct? Or head equal to nil. More than one way, I know the queue is empty, right? So that's okay. Everyone can do it. In queue, DQ display, right? I come to here. I have node star front pointer pointing at the front, and pointer pointing at the end, and I have a counter. Counter is also a luxury thing. You can do it, or you can remove it. It's okay. I come to enqueue, right? So I enqueue where? At the end, right or not? So I come to here. I declare the new node. I set the value, and new node next should equal to what? Nil. I declare a node. I set the value, and this new node next should equal to nil. Correct? So if it is, go back to the beginning here. I declare a node, okay, and I set the value here, and next equal to what? Equal to nil. All right. So far, I created only this, correct? And the name this one is called what? New node. All right. Then I come to here. Is empty. What is the purpose of is empty? If it's empty, mean what? The head is equal to what?
No.
Correct? Doesn't buy anything. If it's equal to nil, meaning what? Front of rear need to equal to what? If it now I don't have, right? The head equal to nil. Now head equal to nil, right? I'm checking is empty. It's empty is what? Checking both rear and front if equal to nil. If both equal to nil, what should I do? Rear and front equal to what? Equal to the new node. Sorry. Right or not? Okay? So both here, front equal new node, rear equal new node. Next, what I do? Else, if it is not empty, right? If it is look like this, not empty, and let's say we go back to this state. Okay? If it is not empty, look like this. Now what I do? Two line of code. What we said? Rear next equal to what? You don't. Rear equal to what? That's it. Done. 2 lines of codes. Yeah. Okay. But here I consider just it is empty. The rear and front will be here. No. What is the purpose of having rear? Just to reduce the complexity. If I need to travel the entire list, then I need to travel n elements all the time. The complexity will be big of n. Now I don't have to travel. What is the complexity?
1.
Big of 1. Constant. Big of 1 meaning constant. By the way, do you have big of 2?
No.
No, only big of 1. Okay? Sometimes I see students write big of 3, big of 4. Okay, we don't have big of 1 meaning constant. Alright. DQ is what?
Removing elements.
Removing what?
Elements.
Okay,
no.
so I come to here. This is DQ, yes. Okay, this is DQ. And of course I pass and X, you know why? Same thing with the array. Okay, is empty. Of course, if empty, the outer false. Now I write X equal the item in the front. Which one the item in front? Here in case 10. Okay. Node, next node, equal front next. Okay, so I move next node to here. Okay, then the front equal to the next node, and that's it. And the counter, sorry, I delete front, and the front equal to next node, and counter minus. Okay or not? Clear? I need to explain. So I have a next node, right? This is next node. So what I do? Okay, next node equal front next, right? Then what I do to front? I need to delete it, right? So we'll remove node 10. Then later I write front equal to what? The next node. That's it. It's done. Okay. Here we are not utilizing head, correct? Okay. Actually, we can ignore front. We can make front equal to head. And that's it. Okay. Just the naming change. We don't have head. In this case here, we don't have head. We don't need head at all. Actually, there is head in the linked list, but we are not using it at all. Okay? Done. Okay? So every time I DQ, I do counter minus minus. Displaying the queue, I display based on how many elements I have. Okay? Or I start from front, keep going next, until next equal to nil, I stop. Right? Displaying the entire linked list, we have done it in the insert and object. Right? Sorry, into the linked list. Good. So I don't think we need to explain this. Right? Just put that's your data, and data equal to next, and storage the rear. This is just all this. Okay? Problematic things is just to print it nicely like this here. You want to print it nicely like this, front equal to this, and so on, and rear equal to this. Why we are doing this? So for example, print 0, 1, 2, 3, 4, and print 5. If 5 equal to rear, then not rear, right? Then I just print out rear. Just this one, make it look more organized or beautiful, which is unnecessary at all. Whether you do it or not doesn't really matter. Okay or not? So queue implementation will never be full, right? And done. Any questions so far? Okay, a reminder, now we have more students. I forgot also to give the attendance. A reminder also that this Friday you will have your midterm exam, right? This is Friday, right? What time?
5,
What time?
5, 7.
5 to 7, right? Okay. Trust me or not, until now I couldn't get the confirmation about the time and all and so on. Okay, let me check now. It's Monday. Probably tomorrow I will get it. By tomorrow I have to get the confirmation. Nothing so far. Okay? Okay, take a break, then we can continue.